Welcome to Air Academy Associates series on using SPC Excel. This video clip is the first of 4 on control charts. In this video clip, we will give a brief review of control charts to give you enough information to understand what makes them work and how SPC Excel implements these control charts. We will also introduce the first of 4 control charts that we will cover in this video series, namely the IMR chart. IMR stands for Individuals with Moving Range Chart. Recall that the control chart represents the voice of the process and that its purpose is to identify outliers, shifts, and trends in the data over time. A control chart is constructed first by establishing a baseline set of data, typically of at least 20 data points if possible. SPC Excel then calculates the mean of this baseline data and uses that as the center line. Then SPC Excel will calculate the upper and lower control limits at plus or minus 3 sigma above and below the center line. As you recall, plus or minus 3 sigma should capture about 99% of the natural variation of the process performance measures. Then the software extends the control limits and we watch the process behave. If we see something like this, an outlier, that tells us this is not happening by random chance. It will also search for shifts, like this data, where all of the data points are well within the control limits, but they're all shifted in a downward direction. Or the software will also look for trends, such as this, where the data is trending in an upward direction. Remember the 68, 95, 99 rule from your training? SPC Excel uses these percentages, 68, 95, and 99%, to develop zones on the control chart as shown on the next page. These zones are, of course, as you can see, plus 1, plus 2, plus 3 standard deviations above the mean. We're going to tilt the distribution, the normal distribution, sideways and extend the zone lines out to relate to the plus or minus 1, plus or minus 2, and plus or minus 3 sigma areas. And you can see from those percentages, the software then develops percentages for each of the zone areas as shown here. 2% for the upper zone A, 14% for the upper zone B, 34% for each of the middle zone C's, and so forth. You can see this. This is all based on the 68, 95, 99 rule. SPC Excel will then use these zones to help us detect certain symptoms that indicate out of control behavior. Now, we are not going to go over these right now because I'm going to give you a graphical example of each of these 7, but I do want to point out the various reasons for out of control behavior. First, let me just mention the term out of control. When we hear that in the English language, typically that means bad things. And of course, it can be bad things, but it can be good things. It can indicate true process improvement, as well as not having good SOPs, standard operating procedures, noise variables interfering with our process, and standard operating procedures not followed. But it could also indicate true process improvement. So let me show you the 7 different symptoms that SPC Excel will look for in your control charts. The first one is a point outside the upper control limit or below the lower control limit. This indicates that this is not happening by chance because 99% of the time the data should fall within the control limits. Another one is 7 consecutive points on one side of the center line. This indicates a shift even though none of the data points are outside the control limits. The trends will be shown when we find a 7 consecutive increasing or decreasing interval. 2 out of 3 consecutive points in a zone A or beyond. Now when you see the word beyond here, what that means is that beyond the lower zone A would be down here. That is to the tail direction of the distribution. The beyond the upper zone A would be in the upward direction, that is in the tail direction of the distribution. And other symptoms, 4 out of 5 that are in the same zone B or beyond. 14 consecutive points that alternate up and down. And in this case, this is the last of the 7, and you have too many data points in the center of the distribution, where the first 6, the data seems to be too far away from the center line. So all of these symptoms have a probability of less than 0.01 or 1% of happening by chance alone. And that's what makes them so powerful. Again, if we go back to the previous chart, when we see this chart, what we're assuming is that we have a stable distribution. And when those symptoms occur, it's indicating we do not have a stable distribution. This distribution could be shifting up or down over time, or becoming taller and narrower, or broader and wider. And that's what the control chart does for us. It helps us determine when the behavior of the control chart is not what we expect it to be. So let's go to the last thing I want to talk to you about before we get into the software itself, and that's SPC Excel uses what is called a control chart wizard to help you determine the control chart you should use. Now, you may already know this from your training, but let me just go through this. First of all, you have to decide what kind of data you have. And the software will ask you, do you have variables data or attribute data, if you are going to use the wizard. I'm just showing you the flow diagram that is the basis of the wizard in SPC Excel. Let's go down the left side here, variables data, and it's going to ask, is your subgroup size 1 or more than 1? And is it less than 10? If it is 1, you're going to use the IMR chart. That is an individual point. You're going to plot individual points with a moving range. And if it's more than 1, between 2 and 9, you'll use an X-bar R chart. Those are the 2 charts that you should know as a practitioner of process performance improvement. There is another chart called the X-bar S in SPC Excel, but this is for data when, for example, if you have 10 data points on Monday, 12 on Tuesday, 14 on Wednesday, and you're using the subgroup as a day, and a subgroup could be a month, a subgroup could be an hour, depending on how fast the data come in. But typically, even if the subgroup sizes are not fixed or not constant, you can make them constant by sampling from the subgroup itself, and the X-bar R chart can always be used. So those are the 2 charts on this side of the ledger that you will want to know, and we will talk about IMR today in this video clip. The other side for attribute data has to do with P charts and C charts. P stands for proportion, C stands for counts. And the P chart can be used whenever the NP chart is used, and the C chart can be used and retrofitted if we have a U chart. So we'll talk about those in another day in another video. Let's now go to the software to show you how to do an IMR chart. We are now in Microsoft Excel, and you can see the Sigma Zone menu item here at the main menu of Microsoft Excel. We click on that and we get the main menu for SPC Excel. Control charts are over in this first main menu item of SPC Excel. Now, let's suppose we have some data from a medical center that tracks the amount of money we spend each month in thousands of dollars on disposable gloves. And here is 16 months of data right there. Now we could plot those 16 months in time order, time sequence, using an IMR chart. Now before I go to the IMR chart, I'm going to highlight both columns here, because if you don't highlight the time, like July, August, September, so forth, and you only highlighted this column, the values on the horizontal axis will be 1, 2, 3, 4, 5 automatically. But if you specify the timing over here, it'll print the first column out as your labels on the horizontal axis. Now let's suppose you don't know what chart you want to use, but you want to chart this data. So you go to control charts and you check on the wizard, the control chart wizard. And as the flow diagram previously mentioned shows you, it asks, do you have variables or attribute data? Well, we have variables data. We go to the next question. Do we have individual or subgroup data? We have individual data. This data is 1 data point a month. And we say next. Now it's going to ask you, Do you want to create, it says the optimal chart for your data is IMR, Individuals with Moving Range Chart. Would you like to create a template for the control chart? If you answer yes, it'll open up a new spreadsheet for you and allow you to input the data. But we already have the data, so there's no need to do that right now because our data is right over here. So we finish with the wizard, we've highlighted our data, we go to control charts and use the individual with moving range chart. We click on that, it says, is this the data you want to chart? We say yes. Are these the labels you want? Yes, they're in column A. And you just say finish. And up comes the chart. And basically, the chart here shows all 16 data points. It shows the upper and lower control limits. The center line is about 30, and this is in thousands of dollars. So these are 30,000. The average is about $30,000 a month that we're spending. And you can see the variation about that line. So this is the individuals chart. The moving range chart has one fewer data points than the individuals chart because the moving range is the range of 2 consecutive data points. This one's kind of hard to see, but if I put my cursor there, that's a 9.1. You know what that 9.1 is? That's the difference between 34.2 and 25.1. It's the difference between data point 2 and data point 3. And it shows on the moving range chart as the second data point here. Okay, but it's the difference between data point 2 and data point 3. And you can see they're all fairly low. There's no red data points to show significant outliers or anything like that in this data, and neither is this. All blue points indicate there are none of the symptoms that we talked about before, and this chart would be deemed as in control. So there's no random, out of random fluctuations occurring. None of those 7 symptoms were occurring. But let's go back to the raw data now. So the team wanted to see if there's any trends in the data. There is not. But let's say we have a new data point, and let's just say it's 10.1. And that comes from the next month. So we put that in, we go back to the individuals chart, and it reminds us, the software knows that you've added a data point in the column where your data that was already plotted exists. And so we want to go into Sigma Zone and we want to update the chart to add that additional data point. And there it is. It shows in red. Why? Because it's one of the symptoms. It's a point outside the control limit. It's symptom number 1. Your out of control symptoms can be seen right here. You can show all of them or you can show none of them. Okay, that's a blue point then. You can show just the ones that exceed, and that's the only symptom there is, and it will show whatever symptoms you want to be seen in red. And that's kind of nice because it allows you to look at all the symptoms individually if you care to do so. There are other things here that you can use to you can add lines. For example, if you wanted to have a goal of getting this cost down to say $20,000 a month, you could say goal, and you could say value at 20, since the numbers are in thousands of dollars, and you could say okay, and it adds this goal to the sheet of paper. So you have other things here that are in your at your disposal to kind of edit and customize your chart as you like. I will show you splitting control limits and removing splits in the next example. So let's move on to the next example, where in this time we're charting wait times to schedule an appointment, and the average wait times for each month for 12 months in 2014 are shown here, 45, and these are measured in days. And so let's suppose we want to do an individual's chart with that and use the January through December 2014 data as the baseline data. We're going to use that as the baseline data. And the reason why is in late 2014, a project was conducted to improve or reduce these wait times. And then we're going to compare the new data after the process has been improved, supposedly improved, to see if improvement really did happen. So let's go do the IMR chart for the baseline data, and we'll see if there are any. By the way, you should always check the histogram on an IMR chart, simply because the zone rules will are applicable only for normal distributions. You want to check to see if you've got a normal distribution, and of course you have the histogram here that shows that it's normal, and you have the moving range chart, and you have the individuals chart. Now these are for times again. These are for appointment times, and the vertical axis is measured in days. Now I'm going to change this vertical axis because we're not using all the sheet here. I'm going to change this, double click on that, come over here and go down to 20. 20, and yeah, I guess that's okay. It'll split it out a little bit more because I know what's going to happen here when we add on the next data point. So this chart, again, all blue points. It's not detecting any out of control symptoms, but now let's add on these data points right there, okay? And let's go to the individual's chart, and let's do what we did before. Let's update the chart with the 2015 data. Now here is where you're starting to see some red data points. This process has obviously changed. These are not the right control limits for our new process starting in January of 2015. So these red things, again, you have more symptoms here. We're showing all of them right now. That's the default. If we show the exceeds, well, these guys, all 7 of these are below the lower control limit. If you look at the center line, well, all 7 of them are below the center line as well. So you might have multiple symptoms occurring with the same group of points as shown here, the zone A, and that's this zone right here. These points are all well beyond zone A. So that symptom is there, and the zone B, of course, adds these points because it's already, the control chart is already starting to see a change in this area of the control chart. So the bottom line is we know what is causing this behavior, and it's good behavior. Why? Smaller is better. Smaller number of days is better. So we're going to what we call split the control limits. So I'm going to come up here to split the control limits, and I'm going to do that in January because that's when our new process started, January of 2015. So we say OK, and here are your new control limits for the new process. The variation, the natural variation, that is the distance between the control limits, hasn't changed much, but what has changed is the average. So the average was 45 days before. The new process is indicating it's jumping down to about 32 days. So good improvement there. And so you can get that by splitting the control limits. You can remove the control limits. You can add lines, like I said. This is a great little way to show improvement is by using the IMR chart when you have data such as this. So that's about what we wanted to cover in the IMR. It's probably the most commonly used chart there is because we get one data point in a particular time increment and we want to plot that data over time, and then we get charts that look like this. And if we split limits, this is your new set of control limits going forward. This was the old process. Obviously, those control limits weren't good for this new process, so we changed the control limits, and now these are your new control limits going forward. Thank you very much for watching, and I hope this was a good introduction to control charts in general and the individuals with moving range chart as well. Thank you very much.